In this video, we will talk about how to parameterize a line and a line segment. So I'm going to do this with an example. So let's let P1 and P2 be these 2 points. And we want to find the parametrization of in part A, a line through the points P1 and P2. In part B, a line segment from P1 to P2. All right, so to motivate this, I want to draw a picture. So we have these 2 points. So we have this point P1 and we have this point P2. So we have P1 and P2. And they are on some line. Okay, so let's draw a line. Let's extend just that segment infinitely to make this line. And I want to be able to describe any point on that line. So let's say I have a point somewhere, even that's not even between P1 and P2. Let's just keep it arbitrary. Let's call this x, y, z. So I want to be able to write what x, y, and z are. Okay, so to do this, I'm going to use vectors. So we are going to use vectors. Use vectors. Okay, so I'm going to begin by just drawing the origin somewhere. So let's say that this is 0, 0, 0, so the origin. And I want some way to know what x, y, and z are. So what I'm going to do is I'm going to draw a vector from the origin to that point x, y, z. So if I want to know the point on the line, and I'm just going to express the x, the y, and the z in terms of this vector that I've just drawn. So I'll put it in component form. What is that going to be equal to? Let's express this vector x, y, z in another way. So I can reach that point x, y, z in another way. If I draw a vector from the origin to the point P1, and I call this vector just P1 with a vector arrow on top of it. Okay, so I'm going to call that P1. And to figure out what P1 is, I just use the coordinates of my point. So that's what's going to start to happen in the next step. P1, let me zoom it out a little bit so I can see it. To get a vector connecting 2 points, so this is connecting -2, 0, 5, and the origin, which is 0, 0, 0, I subtract the 2 points component by component. So I do the point that I end at, P1, minus the point that we start at, the origin. But that just gives us P1, but written as a vector. So it'll give us -2, 0, 5 as a vector. Okay, but there's a little bit more. Because x, y, z is not the same thing as the vector P1. It's P1 plus something. So I need to add a vector to P1 to reach x, y, z. I'm going to need to add a vector that starts where P1 is, that point, and ends where x, y, z is. So I'm going to need to add a vector. I'm going to need to add this vector. So I need a way to determine what that vector is. Okay, so to determine that vector, let's first determine the vector that begins at P1 and goes until P2. Okay, so that vector is P1, P2 with an arrow on top of it. And to find that vector, we subtract the coordinates of P2. We do the coordinates of P2 minus the coordinates of P1. So subtracting the x coordinates, 1 minus -2, we get 3. And the order, again, that I subtract points to get that vector matters here, because I want it to start at P1 and end at P2. That's why I'm doing P2 coordinates minus P1 coordinates. Okay, so then I do -4 minus 0, which is -4. And then -2 minus 5 is -7. Okay, so that's that vector P1, P2. But the red vector is different. So if I just translate that vector and draw it on the side so I can see it a little bit better, that vector is the green vector, P1, P2, but it's just been stretched a bit. So this is some scalar, t, being multiplied by P1, P2, because it's stretching that green vector. And that is what needs to go here, t times P1, P2. Okay, if I add the purple vector P1 to this red vector, which is T times P1, P2, we end up at the point x, y, z, so that should be the vector x, y, z. All right, so now if I multiply t times my vector P1, P2, we end up getting, so the t is going to multiply all the components. We'll get 3t, comma, negative 4t, comma, negative 7t. Okay, and this is supposed to be what x, y, z as a vector is. So x, y, z as a vector. So on the right-hand side, I have two vectors being added. So we just add them component by component. So first I'll get negative 2 plus 3t. And then I'll get 0 added to negative 4t, which is negative 4t. 5 added to negative 7t. Okay, so we have this. So we have these two vectors are the same. And the only way for that to be true, and at this point we're going to be able to write down the parametric equations for the line, is if x, and I'll write x as x of t, if the x coordinate is negative 2 plus 3t, okay, so this x and that x coordinate, they got to be the same, and the y coordinates have to be the same, so y of t is going to be equal to negative 4t, so let's highlight those, so the y's are equal, and the z's are also going to be equal, so the z component here is equal to the z component there, so we can say that z of t equals 5 minus 7t. Okay, so t is our parameter here, and in terms of the picture, t represented how much did we stretch or shrink this green vector by. And of course, t could be a negative number, it could be a positive number, and it could be as big as we want or as small as we want. So t is any real number here, and when it is any real number, we get the equation of a line. So that would be the equation of our line right there. If we wanted a line segment instead, if we just wanted the line segment that started at P1 and ended at P2, what we do is we have to limit the values that t can be. So it'll be the exact same equations. So the exact same equations. But if I wanted to start at P1, well, P1 would correspond to letting t is sort of the stretching factor, be 0. That's what would put us at P1. And if we wanted to put it at P2, then the stretching factor should be 1. In other words, we shouldn't stretch it at all. So t needs to be between 0 and 1 with these same equations, and if we have that, then we get a line segment instead. But the key idea here is these equations for this line and this line segment are all motivated by vectors. Okay, so now that we've done it for this example, we can state the formula in general. Okay, so in general, let's write down formulas for first a line through the point x naught, comma y naught, comma z naught, that's parallel to the vector ai hat plus bj hat plus ck hat. So the parametric equations are going to be x of t is going to be that x coordinate. Whoops, let's put this in black actually. So the x coordinate of that point, it goes through x naught plus a sort of describes the direction of this parallel vector, but the x component of it, and then times t. And then we do that for each of the components. So the y component, y of t, what that is in parametric form is the y component of our point plus the y component of this parallel vector, which is b times t. And then similarly, z of t is going to be z naught plus ct. Okay, so we have these three equations, and for this to be a line, t needs to be any real number. So in short, each of these parametric equations contains the coordinate of a point that the line goes through. So x of t contains the x coordinate, x naught. Y of t contains the y coordinate, y naught, and so on. And then plus something times t, where that something is the component that showed up in the vector that it's parallel to. Okay, so even in our picture above, that was happening. So even in this picture above, notice that when we looked at the vector that it was parallel to, which was P1, P2, when we looked at, for example, the first coordinate of that, which was the 3, that was and that was the x coordinate of that vector. That's showing up in x of t here. That's showing up in x of t. All right. And that's true across the board. So the -4, which is in the y component, shows up in the parametric equation for y of t. And then similarly, the -7 shows up in the parametric equation for z of t. Okay, cool. All right, so we have that general formula for the line. Now let's do line segment. So what if we want a line segment that goes from the point x0, y0, z0 to the point x1, y1, z1? So I'll start it off in the same way. I'll have an x0 plus something, y0 plus something, z0 plus something. And then I'll have something being multiplied by t. Something being multiplied by t for each of these. And what that something is comes from the vector that connects these 2 points. So if I call this point P0 and I call this point P1, the vector from P0 to P1 is going to be x1 minus x0, comma y1 minus y0, comma z1 minus z0. And those components are what goes in these parentheses. So it's x1 minus x0, y1 minus y0, and z1 minus z0. All right, in terms of our goals for this section, we have now talked about how to find the parametrizations of a line and a line segment. In the next video, we will do an example where we parametrize things that aren't functions in the sense that y is not a function of x. So things like circles and ellipses.